Hi, in this session I'm going to show you some basic features of Excel, including some tips for helping you with productivity. In another session, I'll go over some of the more advanced features of the software. Excel is a robust spreadsheet platform with applications that can range from a simple collection of information to a complex model engine. We can use Excel to calculate values, but we can also use it as a database manager or organizational tool. Here we'll focus on some features that will make creating basic financial spreadsheets easy to construct and maintain. Let's start by reviewing how Excel looks at the data we put into each cell. Excel is based on a relative reference system. If we put data in cell B7 and then reference that data in cell D2, Excel knows to look for the data in a cell that is 2 columns to the left and 5 rows down. If we copy the formula used in D2 to F2, Excel will still look for the referred to data in a cell that is 2 to the left and 5 down, in this case D7, not B7. Understanding this relative way of referring to cells will come in handy as we strive to make our spreadsheets efficient and accurate. We can change how Excel looks at these relative cell references by explicitly telling Excel the reference is absolute. To do this, we can toggle through the different reference formats. We've designated cell D2 to be equal to B7. This is a relative reference. If we want Excel to always look in column B, we can specify that by placing a $ in front of the B. If we want Excel to always look in column 7, we put a $ in front of the 7. By placing $ in front of both the B and the 7, Excel will now always refer back to the contents of cell B7, no matter where we copy the formula to. We'll use this a lot as we build our financial models. Another handy feature of Excel is its ability to recognize and extend a series, such as a simple number series, calendar series, or months. We can also use this to quickly extend a formula. If we are modeling the amount of money we are contributing to our retirement plan, and we expect that today's contribution will grow by 3% per year, we can easily create this formula and then extend this out to our retirement date. We could then use this information along with the time value of money functions to then project an estimate of the final value of our retirement account. Note the use of both absolute and relative references in this formula. Excel also comes with many embedded functions. Sometimes these functions allow us to calculate something that would be very complex algebraically, such as solving for the yield of an investment, which would require us to calculate roots or sometimes even use log functions. And a little introduction to the syntax Excel uses may help. First, we can always use the function wizard. The function wizard looks different depending on whether you're working in a Mac or a PC, but it works the same in that you choose a function to use and then you can work through that function by placing the relevant information in the spaces provided. One trick we can use is to label the cells where our data is. In this instance, cell B9 is the data where I will have the present value of my investment. I can go to the formula bar in the upper left-hand side and replace the cell address B9 with PV. I can do the same for B10 and replace it with FV. I can do the same with B12 and replace it with rate, and the same with B13 and replace it with MBA. Now I could create a formula in B11 for payment, and I could type in the words rate, NPER, PV, and FV, and the formula would now calculate for me. Let's use an example. Suppose we have an investor who is 32 years old, who plans to retire when he is 67. He believes he will need $1,375,000 when he retires at 67, and he believes he will earn a 6% return. Now I can substitute in, I can have the contents of B10 be equal to this amount needed to retire. I can have the rate equal to the value in expected return. I can have the number of periods equal to the years to retirement. And I can assume that my present value is 0. I've not started to save yet. And we can see here that our friend would need to save over $12,000 a year for the next 35 years to reach his retirement goal. Now I have a spreadsheet that I could use for anyone. Say we have someone who's 47 and already has an investment portfolio of $325,000. Then I know that I will need to make that a negative number so that it shows that it is an investment in cash out. I've made the investment, and this solves for a payment of $9,043.78. There's a lot of flexibility here. That's it. We can now use this worksheet for anyone. Okay, that's enough for now. Join me later for a tour of other features of Excel. Thank you.